Hi, I'm Heather, and as you can tell from my majors, I like science a lot. This led me to the study abroad program that I'm about to talk about, which is Sea Semester. Sea Semester is a very unique program in that you spend 6 weeks in Woods Hole, Massachusetts, designing a research project, and actually going to the ocean and actually performing your research on the ocean. So I will briefly talk about what Sea Semester is, both the shore and the sea component, and what I did in my research, which was on ocean acidification and comparing carbon and iron concentrations between the open ocean and these atoll islands we stopped at. So the shore component, you spend 6 weeks in Woods Hole, Massachusetts, and you essentially have an entire semester of classes in 6 weeks. So they are very intense. And we had courses in nautical science. So we learned about celestial navigation. Pretty much you can find out exactly where you are in the entire world just by using the celestial objects in the sky, so the sun, the moon, and the stars. We also learned about sail theory, which is how a sailboat moves and what forces are on a sailboat to make it move. And then finally we learned about how to chart where we are. So we use the information from celestial navigation to chart where we are in the world. And our second class that we took was Ocean Science and Public Policy, where we kind of got exposed to maritime history and culture to get us used to thinking nautically. And also, my specific program was on climate change, so we talked about the public policy issues with climate change. And finally, kind of the meat and potatoes of the shore component was this Oceans and Climate course, where we had an intense crash course in oceanography and climate change and how climate change actually affects the oceans. And in a 6-week period, having to know absolutely nothing about oceanography and then being able to write a 7-page proposal saying what you want to do in the Equatorial Pacific. So after we did all that, we traveled to Honolulu, Hawaii, where we sailed 3,500 nautical miles from Honolulu to Honolulu. And we had 2 port stops, one at Palmyra Atoll, which is about 6 degrees north of the equator, which is right here. And then we stopped at Christmas Island, which is about right here, so about 2 degrees north. And then when we finally returned back to Hawaii, we spent a few days sailing around the Hawaiian Islands and watching the humpback whales who had come from Alaska to come and breed. So it's pretty incredible. So you're probably wondering, like, how do you have academics on a boat? Well, we had class every day at 14:30. We had to use military time because the boat is moving 24 hours a day. So you can't really use the traditional time system. And we kind of had like the practical applications of what we had learned on land. So we had practical nautical science. So now we were doing the celestial navigation that we had learned about. We were sail handling, so we were the people that set all the sails, striped all the sails. We were the crew. So we cleaned the boat, we did the food, we did the boat checks, we did all that stuff. And on the other side of things, we had this entire science portion of my cruise, where we learned the basic oceanographic lab techniques. So we got water and organismal samples and nutrient samples. And then once we used this data, we could actually learn about what we had written our proposal on in Woods Hole. So we had to analyze it, and we had to finally write our paper on New Year's on a boat. So what I did my research on was ocean acidification. And ocean acidification is the lowering of the pH of the ocean caused by increased atmospheric carbon dioxide. So as we know, there is more carbon dioxide in the air now than there used to be 100 years ago. And everyone always wonders where it goes. Well, it goes into our oceans. And it gets dissolved, but it doesn't stay as carbon dioxide. It actually reacts with water to become carbonic acid, which is the weak acid we find in sodas. But it doesn't stay this way either. It actually dissociates into bicarbonate and carbonate and H+ or hydrogen ions, which we normally consider acid. And this is such a problem because carbonate is actually pH dependent. So the more acidic your solution is, the less carbonate you have. And calcifying organisms, or organisms that make shells, actually use carbonate to build their shells. So if you have less carbonate in the water, you're going to have more problems with these organisms that use the carbonate to build their shells. So what I wanted to do with this was compare the carbonate ion concentrations between the surface water, or the thermocline, of the Equatorial Pacific and the surface water at both Palmyra and Christmas Island. And atolls are so unique to this process because an atoll is an island that used to stick out of the water and has sunk back into the ocean. And the only thing left is this coral reef structure that surrounds it. And coral is actually made of calcium carbonate or chalk. And so you have these like large sources of carbonate. And I wanted to see if it would buffer or kind of reduce the effects of ocean acidification occurring around those islands. So what I learned was that Palmyra actually had a lower amount of carbonate, which I didn't expect, than the open ocean, and Christmas Island actually had a higher carbonate ion concentration. And I believe this was because Palmyra is this very robust biological coral reef system. So it must actually be taking the carbonate from the open ocean and using it to further build its coral reef structure. Also, it's very, very tiny, so it doesn't have a large source of carbonate to actually, buffer the effects of the ocean. And it's in a part of the world where it rains quite a bit, so the amount of the water that's sitting there doesn't stay there for very long, so it gets flushed out very quickly. On the other hand, Christmas Island actually had a higher carbonate ion concentration, which suggests that it is buffering the effects of acidification right next to the island. And this is because the coral reef is the exact opposite of Palmyra. It was very unhealthy, things were dying, so this was probably releasing carbonate back into the ocean. Also, it is the largest atoll island in the world, so it has a very large source of carbonate to take from. And on top of that, it's also a desert island, so it doesn't rain very often. The water that's there doesn't stay there for very long. It stays there for a very long time, so it's probably able to stay in that water and buffer the effects of the ocean acidification happening. But that's what I learned at Sea Semester, and thank you for listening.